Let's step back for a moment and try to understand what problem Docker really solves. This story didn't start with Docker, it started much earlier. Chapter 1: The Age of Bare Metal. In the beginning, all applications were running directly on physical hardware. One machine, one operating system, multiple applications, all sharing the same resources. There was no real isolation. If one application consumed too much memory or crashed unexpectedly, it could bring down the entire system. Scaling was simple but expensive. If you need more capacity, you buy more servers. Gradually, investment on hardware started defining your limits because scaling meant buying more powerful machines, and every fix came at a high cost. Chapter 2: The Rise of Virtual Machines. Then came virtualization. Hypervisors like VMware and Hyper-V allowed multiple operating systems to run on a single physical machine. Now, each virtual machine had its own operating system, its own library, and its own applications. Isolation improved dramatically. Servers could be consolidated, resources could be optimized, cost could be reduced. It was revolutionary, but there was a trade-off. Each virtual machine carried an entire operating system. They were heavy, slow to boot, and resource intensive. We had improved isolation, but at a higher cost. Chapter 3: The Container Awakening. Developers wanted something lighter. Instead of virtualizing hardware, what if we virtualize the entire operating system itself? Containers shared the same host kernel but kept the applications isolated along with their dependencies. This meant faster startup times, smaller footprints, and easier portability. Technologies like LXC laid the groundwork. The idea was powerful but still complex to use. Chapter 4: The Docker Revolution. And then in 2013, Docker changed everything. It didn't invent containers, it made them usable. It made packaging simple, bundled the applications together with its dependency into a portable image. It made deployment fast, containers start in seconds. It made consistency real. The phrases like works on my machine but breaks in production started disappearing. And it built an ecosystem: Docker Hub, orchestration tools, and integration to Kubernetes. Docker didn't just improve virtualization, it redefined how modern software is built, shipped, and scaled. It became the bridge between the developers and operations, and it helped in empowering the DevOps and cloud native era. It is not a sudden invention, it's the natural evolution of how we learn to run the software. Now let's deep dive and understand the problem faced by the developers and how Docker solves it. A developer builds an application, it works perfectly on their machine, but in production, it breaks. The problem could be anything: different operating system, different runtime version, or the production environment may not have the required dependency installed. Docker solves this by packaging the application, its runtime, and its dependencies all together into an immutable unit called image. That image is shipped to production. We don't rebuild the application there, we simply run the image. When an image runs, it becomes a container. Image is a blueprint, and container is the running instance. The behavior stays consistent because the same image runs in both the environment. And that's how Docker solves the environment and dependency differences, not by changing the code, but by standardizing how it runs.